Hi everyone, this is Will McCarley, and I will be discussing mastering lean in digital manufacturing for my ME 3210 Design and Manufacturing course project. So to start us off with, what is lean in digital manufacturing? The entire idea behind this system is that we are minimizing waste and maximizing value. And this should be applied to every single company, but specifically to manufacturing when the goal is maximum output. And as far as digital manufacturing goes, it's the implementation of technology such as IoT devices, data analytics, AI, cloud systems, and many other technologies to automate, monitor, optimize systems. So here to the right, I have a diagram of seven different kinds of corporate waste. Super common in every single business, but this is kind of preached with consulting models. And that is that defects, inventory, overproduction, transport, movement, waiting, overprocessing, all these things can accumulate to lose companies millions of dollars. So our whole idea behind lean and digital manufacturing will be to limit this waste. So ways we can do this is with um, robots. As seen on the right, we have a manufacturing line that was previously done by hand, was automated using robot arms to grab pieces and assemble parts. So these smart factories, they always have real-time dashboards so that we can monitor KPIs and use SPC charts to ensure that we're on target with things, and predictive maintenance on the robots themselves, which I'll elaborate on later. Digital twins for process simulation and rapid decision making. So you get a lot quicker of decision making with a machine because it doesn't think twice, doesn't doubt itself. And then lean consulting engagements. So we need to help clients cut out cycle time. We need to reduce their inventory and streamline product lines. So look, going back to what I was saying before, my experience with lean and digital manufacturing is for a big four consulting firm. And recently my project has been working on optimizing a CNC milling machine that's used to drill for fridge gaskets. And the whole idea is that I'm going to be implementing IoT and AI and data visualization to ensure that clients can see how you can model systems to maximize efficiency and make sure all KPIs are on target. Um, so the CNC device relies on highly precise programmable data tracks to go through the part that it's milling, and it gives really, really high precise cuts. However, we have issues with efficiency as you can only cut one piece at a time. So my experience is I used IFM Mineo's inductive sensors as seen to the left, and the IFM Mineo accelerometer sensor seen to the right to implement predictive maintenance, data visualization, and digital manufacturing IoT configuration on the CNC device. So I used an IoT gateway essentially to hook up three different conductivity sensors, inductive sensors, same thing, to different doors on the CNC machine. And you could track optimal cycle times using just with a timer when the door was open and closed at maximum efficiency. You take the mean of that value and implement that as the ideal cycle time. And then we'll use these inductive sensors to determine whether or not doors are open or closed and why they're open and closed, whether it be for maintenance, breakdown, or just inefficient cycle time. And we can translate those numbers and use some data visualization topics that I'll talk about later to really summarize things for corporate leaders, which makes it a lot easier for everyone to digest. And then the inductive sensor is used for the predictive maintenance. So you can the accelerometer is used for predictive maintenance. This vibratory sensor is strapped to the cutting piece of the CNC device, and it measures the vibrations, temperature of the system. And we can use this data, average it to see when the crest or the amplitude of the wave is getting too high. We can infer that there's an issue with the CNC milling device, which can cause poor fridge gasket output. So the whole idea here is making sure that we keep our vibrations consistent, steady, and low. So going back to just the overview of digital manufacturing and lean manufacturing. So there's a huge, huge opportunity now this decade with manufacturing optimization because of AI. So AI has the power to do so many different things with data and just configuring, talking to different machines to ensure that almost the robots think like people would if they were working the manufacturing line, which is fantastic because that means less work for us and less money for the company to pay at least. So using cloud-based software such as MES and ERP systems, these can be used to ensure that all the APIs, our RPAs are on track. And I'll be gaining more experience with that this summer working for another software consulting firm. Um, so we can push for data-driven continuous improvement because every single day automation improves. We get better, AI grows, and other discoveries are made. And not only do we need to focus on efficiency, but we need to look on green, lean, sustainable, and efficient processes. So some technologies to know, like I said before, with this project that I was working on for this consulting firm, I use these IoT sensors and edge devices to use Grafana, as seen to the right, which is a really, really helpful data visualization uh, software that's open source, so it's free. You see what they're doing to your data, it's great. Um, and then another example of these is like Power BI or Tableau. They're good, but not as great as Grafana, in my opinion. And then, we use some automation platforms, PLC and SCADA. But I believe that there's so much power in the data visualization, and that is particularly my favorite. So going into some just lean tools that get preached at every single consulting firm, we've got VSM, but I'll focus on 5S and root cause because that's what I have the most experience with. But 5S, as seen to the right, with this simple little diagram. It's the idea of sort, straighten, sustain, shine, and standardize your company. So these may sound like pretty trivial ideas, but when compiled and enforced throughout the entire rigidity of the company, you can really see some insane improvement. Particularly, in my opinion, with standardizing, I think it just makes so much less room for error and makes sure that it ensures that every single employee of the company is on track and has the right idea in time. Root cause analysis, this is about problem solving. This is what we do as engineers, finding issues in systems such as like a line to brew soda. If you have an issue with some solenoid in a valve and you've got to figure out pressure differentials and what's going on, at the end of the day, it might just be the wrong valve. So you need to be able to take a step back and find root cause solutions for broken issues and reduce waste there. So none of this would be possible without QA and SPC. But quality control is essential to every single lean manufacturer because we need to ensure that every single part that we're producing, every product that we're producing is on spec. And this is also what SPCs help us do. We ensure that metrics are tracked and that data is actually stored and used within the company so that we get our best use of it. Going back, this is some importance, capabilities, and limitations of QA and SPC. You really just need the you need buy-in from the company. That's the most important part. None of this works without accountability, and that comes down to ensuring that your employees understand what is expected of them. So skills to develop, consulting, the whole idea is, we need to work on client management and problem solving frameworks like root cause problem solving that I just mentioned. Technical stuff, Python, SQL for data analysis. These are essentials. CAD for layout design. I have a diagram to the right of Robot Studio, the super simple lean manufacturing tool that we use to program robots to do things like pick up bottles and move them. Communication, we need to make sure that all communication is streamlined. And strategy, we need to ensure that return on investment is maximized. So, in conclusion, the whole idea is that lean and digital equal future ready manufacturing. Thank you.